Science in the morning, science in the evening, science at supper time. When science is on the internet, you can have science anytime with Mr. Francis.
Hey everybody, it's Mr. Francis here. Just wanted to teach you about organic compounds today. We're going to go over the basics and then we're going to go into carbohydrates, and that's it. We're not going to go too deep into this. I'll make a couple more videos following up the rest of this PowerPoint. But first off, let's start talking about organic compounds. We already should have learned this. This is not new. We've heard about it in digestion and in the organic compound section of our unit at the beginning of the year. But we'll talk about it again just to refresh your memory because a lot of people have been having questions out there. So, first off, let's talk about the word organic. What the heck does that mean, right? Organic. You've all heard this before, maybe at like the supermarket or something like that. You go there and there's a little tag that says organic, and your watermelon costs like $17 more because it says organic. But that's maybe you've seen it on apples, or maybe even some flour that you're going to make bread. Ooh, I've got some organic bread. Organic bread, it must be fantastic. Well, it doesn't mean anything special. But in science, organic means something a little bit different. When we talk about organic in science, it means that it contains the element which is known as a pure substance, carbon. Okay, so anything organic contains carbon, or rather anything that contains carbon is considered organic. You and I are both organic, and so are apples and flour and watermelon and your dog and your cat. All these things are considered organic. Okay, so here we have the periodic table of the tab for carbon. Okay, you can see it's 6, meaning it has a proton, 6 protons in it. Okay, let's move forward. Now, when we talk about the elements of life, or just elements in general, we have to really figure out what elements are. You and I were made of a handful of them. Nothing much, just a small handful of elements, and in the right order, it makes you, you, and me. And we could find these elements at a hardware store pretty easy. For instance, like a bag of manure. You know what that is? That's cow poop. Okay, so this helps things grow because, you are what you eat, and plants absorb the nutrients from the dirt and become the things that we eat. So when we talk about the elements of life, we have 6 different elements that we find in all living things. CHNOPS, or as I like to say, Chinops, like a Pokemon saying its name, Chinops, Chinops. Okay, so the C stands for carbon. Again, you're carbon based. We have H for hydrogen, N for nitrogen, O for oxygen, P for phosphorus, and lastly S for sulfur. Now, the first 4 are the big ones that you're made out of. I mean, we are constantly breathing in nitrogen, tons of it all the time, but we can't absorb it through the air. We can only absorb it through the food that we eat. We get our oxygen and our hydrogen from the food that we eat, the water that we drink. Okay, and carbon is found in every living thing. So anytime you eat something that has carbon in it, you're absorbing it into your body. So when we say the word organic compound, we have to first figure out what the word compound means. Now, we know what organic means, but what does compound mean? Well, compound is a substance formed when we take 2 or more elements that chemically unite, so they attach to each other. For instance, salt. We all like salt, right? We put that on our food and on our french fries, and like some of you might just put it on your hand and lick it because you're kind of weird like that. I'm not judging, don't worry. But when we look at salt, salt is made of NaCl, which is sodium and chlorine mixed together. Now, these 2 things together are delicious on potatoes, but separately, each one of these elements, Na for sodium and Cl for chlorine, each one of these, they could kill you, but together they taste fantastic. Now, when we talk about compounds and elements and chemistry or science, be aware that you really got to know what you're talking about, because some people like to misconstrue things and make you think that things are bad for you when they're not. For instance, if I said dihydrogen monoxide can kill you if you have too much or too little, you might get scared. If I said it's found in all of our sinks, you might get scared. But if you know science, you know that that's just H plus O, which is H2O, or water, okay? So just because it has a big scary name and some letters doesn't mean it's something you actually have to be afraid of. So again, a compound is when 2 things or more click together and they form something, okay, like NaCl or H2O. So when we talk about organic compounds, well, it's a little bit different. Okay, and by different, I mean exactly the same. First off, it's something that contains carbon. Okay, so it's a compound that contains carbon. So it's carbon attached to something else. Now, could it be a whole bunch of something else? Yeah, it could. For instance, a spoonful of sugar right here, delicious sugar. Everybody likes sugar, right? Sugar contains carbon. And we know this because glucose, which is the basic form of sugar, what we call a monosaccharide, if you look at its skeletal structure here, you can see the elements that make up a molecule of glucose. And you can see all the C's that are on here that are glucose. I'm sorry, carbon. So when we talk about organic compounds, we have 4 different types. We're only going to talk about one today in depth, and we'll save the rest for the others. First off, we have carbohydrates. Could you look at this picture and pick out one that might have some carbs in it? Um, I'll give you a second to look at that. Then we got lipids. Okay, maybe you've heard that word before. Maybe you can look at the picture on the right and find some lipids. Protein. I'm sure you've all heard of protein before. Almost every single one of these you're going to find protein in. And lastly, nucleic acid, something we don't really look for when we look at food because it's kind of weird to think about, but it's in every single one of these pictures to the right here, whether it be the egg, the broccoli, the quinoa, okay, these chia seeds, some lentils, maybe even a handful of cottage cheese. All of these have nucleic acids. And most of the things on here actually have all 4 of these organic compounds, but some only have a few, or are missing one at least. Okay, so let's move forward. First off, what we're going to talk about today is carbohydrates, also known as saccharides. Saccharides and carbohydrates, same thing, is a really fancy name for, you know, this guy right here, sugar. Okay, so when we talk about carbohydrates, we're talking about sugar. So where do we find carbohydrates in the food that we eat? Well, candy's a big one. Everybody loves candy. I am a huge fan of these orange slices, just FYI. If you ever need to provide me with candy, that'd be the one that I want. So candy is full of sugar. How about pasta? A lot of you may not think about spaghetti and ziti as something full of sugar, but in the end, that's what it all breaks down into. Soda, of course. Now, even Diet Cola has a form of sugar, though it's not one that your body can use. It's still sugar inside it. Bread, okay, bread turns into sugar in our body, and fruits and vegetables. Now, I guess the main question is, where do all of these things come from? Well, it's plants, okay? We get our sugar, our candy, our pasta, our breads, even the syrup that's inside these sodas all come from plants. Here's a picture of a sugarcane plant, okay? And sugarcane plants, what they do is they make sugar for themselves during photosynthesis, and we rip them down and eat them because it's delicious. Okay, nowadays, most of our sugar comes from this bad Larry. So corn, that's awesome. Everybody loves corn. I don't really like getting my sugar from it, though. So what is the function of a carbohydrate? What's the function? What's it do? Well, first off, it provides us with quick energy, relatively. We break it down almost instantly as we eat it. Some of them take a little bit longer to break down because there are different types of carbohydrates. But the main job of a carbohydrate is to provide our body with energy so it functions correctly. So, for instance, if you were to drink this juice made of what looks like carrots and oranges, okay, this is going to absorb quickly into your body. Kind of like this little girl eating a handful of sugar. In reality, both of these are going to provide us with almost instant energy. While on the other hand, a bowl of oatmeal in the morning, it's going to take a longer time to break down, and as it takes time to break down, you'll be able to absorb it into your body more slowly, and it's actually a lot better for you depending on the situation. Okay, so what are the 3 types of carbohydrates that we're talking about today? Well, the first one is called a monosaccharide. Mono means one, and saccharide again means sugar. So a monosaccharide is one sugar. This is going to be super easy for your body to absorb into it, and we're going to use it super quick. here are three different examples of monosaccharides we can find in nature, like glucose, which is our body's favorite, fructose, and galactose. Now, disaccharides, these are still considered fast absorption. They're a simple sugar, and what they do is um, they combine two monosaccharides together. So di means two and saccharide means sugar, so disaccharide is two sugars. So here we can see two monosaccharides stuck together, okay? And that's going to form something called sucrose. This is the stuff that we think about when we eat normal table sugar. Okay, so when you pour sugar on your frosted flakes that totally don't need sugar, or you pour it in your coffee or your tea or whatever you do with sugar, um, this is what you're actually eating. This is glucose and fructose mixed together, and it tastes delicious. Now, if you were to eat just a monosaccharide by itself, it doesn't taste that good. That's why we don't pour glucose on our breakfast cereal, because you wouldn't like it. Okay. Polysaccharides are the last one, and polysaccharides are three or more sugars. Poly means many, and saccharide again means sugar. These are going to be slow absorption, so these take a little more time to break down in our body, and our body doesn't get hit with an insulin rush as quick when we eat these. Now, again, this is going to be the stuff that you find in things like potatoes and breads and starches. But poly, meaning many, is a whole bunch of sugars attached to each other. Now, this again is a small one. This is only 5, but it's still considered a polysaccharide. Let's see. Now, I really like this chart. If you're taking notes with me, this chart's going to help you out a lot. Okay, so this is just about carbohydrates. We have simple sugars that break down into monosaccharides and disaccharides. Okay, both of these turn into glucose, and glucose again provides energy for our body. So it could be energy for our brains or our muscles. It could be glycogen, which is made and stored in the liver. It's also stored on our muscles. And any extra that we don't burn off turns into fat in the end. So sugar actually turns into fat. Like anything, if we eat too much, it turns to fat. But sugar, especially simple sugars, really like to turn to fat real quick because our body can't process them when we eat huge amounts of them. Now, complex carbs, on the other hand, like starches and fiber. Starch, you can think of bread, or you can think of a potato, even corn. Starches are going to break down into glucose, but they're going to take a longer time to do so in our body. So it doesn't hit our insulin levels don't spike as quickly, which is great. But they still do provide us with sugar, and that sugar can turn into fat. So when you eat a whole bunch of French fries, even though they're complex carbs, you know what's going to happen. Fiber, on the other hand, is a little bit different. Fiber is really important to our diet, and most Americans, we don't eat enough fiber because we don't eat enough plants. We eat a lot of processed garbage. Now, fiber itself basically sweeps out your insides and gets rid of your fecal matter, your poop. And when we talk about fiber, there's two main types. We have soluble and insoluble. Soluble is a kind of fiber that we can digest, but it doesn't really do too much to our body. But insoluble fiber is the kind that actually pushes everything out of us. It's important to get enough fiber in our diet, because if you don't get it, you could be constipated, you could have some backup, or you could have some bowel issues, and nobody wants any of that. Okay, so next, what are the elements that we find in carbohydrates? Well, we said that elements earlier were pure substances, and in this case, we have C, H, and O. So carbon, hydrogen, and oxygen are all the elements that you're going to find in a carbohydrate. CHO. Say it with me. CHO. Okay, CHO. Now, moving forward, we have to talk about this word, monomer. Every organic compound has a monomer, and the monomer of a carbohydrate is a single piece of it, okay? For example, the monomer of a carbohydrate is going to be a monosaccharide. Now, the word monomer means a single piece, and if you look at this picture that I put up here, each one of these spheres could be the monomer of this chain. Depending on how many spheres we have on here, changes the type of chain that this can be used for. Now, this is the kind of chain that you would find like on a bathroom light or something like that, or on a fan. The monosaccharides, though, again, don't forget, are glucose, fructose, and galactose. All of those are the monomers of a carbohydrate. And when we move forward on the next episode with lipids, you're going to see that the monomer is different. Okay, again, a monomer is a single piece made up of the elements CH and O. Well, guys, it's been a pleasure. I hope this helped you review some stuff. Let me know if it did, and yeah, have a great one. Be excellent to one another.